Hello students, good morning. Welcome to online learning, standard 12, subject chemistry. Dear students, through online learning we have completed lesson 1 metallurgy and lesson 2 P block elements 1. And from this video we are going to start the new lesson, that is lesson 3 P block elements 2. Students, this is the continuation of lesson 2. In lesson 2, what are the things we have discussed? We have discussed about group 13 and 14, their compounds, properties and uses. Everything we have completed in the completed using the previous videos. And from this video, the group 15, group 16, it is nitrogens, chalcogens, halogens and finally noble gases. About them we have to discuss their compounds and the methods of preparation of their compounds, then properties and uses. All these things we have to see using the coming videos. Okay, let us move on to the video. Dear students, in this video the things which we are going to discuss I have shown here. First one is occurrence. You know about occurrence. Okay, what is called as occurrence? The sources. From where do we get nitrogen, where do we get phosphorus? So the group 15 elements and their sources will be explained under the heading occurrence. Then second thing is physical properties, about their atomic numbers, mass numbers, density, then the isotopes available. Everything will be discussed under physical properties. Then about two molecules we have to see, they are nitrogen and ammonia. Okay, the methods of preparation of nitrogen, its physical properties, its chemical properties and uses, everything we will discuss under the heading nitrogen. And finally ammonia, the method of preparation of ammonia, its physical properties, chemical properties and finally uses. So these are the things we are going to discuss using this video. What are they? The occurrence of group 15 elements, then their physical properties, then a detailed discussion about nitrogen, also a detailed discussion about ammonia. Okay, now first we have to remember the elements of group 15. Dear students, these are the elements present in group 15. Let us read one by one. First one is nitrogen, second one is phosphorus, third one is arsenic, fourth one is antimony and finally bismuth. So these are the elements constitute group number 15. What are they? Nitrogen, phosphorus, arsenic, antimony and bismuth. First we have to aware of all these things because these are the major or essential parts we need to know when we have a discussion about group number 15. Okay, once again tell me, what are the elements present in group 15? They are nitrogen, phosphorus, arsenic, antimony and finally bismuth. Okay, now the first heading we can discuss, that is occurrence, the sources of group 15 elements. Here first we will discuss about nitrogen. Okay, dear students, we all know about the constitution of air. Can you please tell me, air is composed of what? Yes, air is composed of 78% nitrogen, 21% oxygen and remaining 1% the other gases. Okay, so that is given in point number 1. The main source of nitrogen is our atmosphere. From our atmosphere we can extract how many percentage? 78% of nitrogen. And the other source of nitrogen is, one is sodium nitrate, which is also called as child saltpeter, and potassium nitrate, that is called as Indian saltpeter. Okay, so these are the other two sources of nitrogen. So there are three sources for nitrogen is given. One is atmosphere. In the Earth's atmosphere around 78% of nitrogen is present. From there we can extract it. And the other sources are sodium nitrate and potassium nitrate. Then come to phosphorus. Dear students, phosphorus is the 11th most abundant element in the earth crust. This point we have to keep in our mind. It is 11th most abundant element and it occurs in the form of phosphate salt. What is the formula of phosphate? It is PO4 3-. It is the formula of phosphate ion, and there are two examples for phosphate ions are given. They are fluoraptite and chloraptite. These are the examples for phosphate salts. So from this phosphate salts, what we can extract? We can extract this phosphorus. So these are the sources for phosphorus. It is 11th most abundant element and it occurs in the form of phosphate salt, and the examples for phosphate salt is fluoraptite and chloroptyte. Then thirdly, we have to discuss about the remaining elements, that is arsenic, antimony and bismuth. Their occurrence is not so abundant. They occurs only in low extent, and mainly they occurs in the form of their sulfides, arsenic sulfide, antimony sulfide and bismuth sulfides. They occur only in very lesser amount. So with this, the occurrence are over. We have seen the occurrences of nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, now in this slide I have taken the physical properties of group 15 elements. There are so many physical properties given in your textbook, but I have taken only a few, the things which we need to remember, only those things I have taken. And in this physical properties, the properties we are going to see is, first one is physical state, second one is atomic number, third one is isotopes of the particular element, and finally electronic configuration. And even in this electronic configuration, I have taken only the valence shell electronic configuration. Now come here, the elements are nitrogen, phosphorus, arsenic, antimony and bismuth. First let us see physical state. Physical state in the sense, as you know already, we have to represent whether the elements are solid, liquid or gas. Dear students, in group 15, the only gaseous element is nitrogen. Nitrogen only is a gas. All the remaining elements are solid in nature. Phosphorus is solid, arsenic is solid, antimony, bismuth, everything is a solid. So the only gaseous element present in group 15 is nitrogen. Then second one is atomic number. Okay, for remembering the atomic number, I have told you a trick. Can you remember how it was? We have to know the atomic number of the first element. Here the first element is nitrogen and its atomic number is 7. Then what we have to do to get the atomic number of the successive element? We have to add 8. 7 plus 8, that is equal to 15. Then for next element, what we have to do? We have to add 18. 15 plus 18, that is equal to 33. Then again what we have to do? Add 18, that is 51. Again add 32, that will be equal to 83. Okay students, see the isotopes now. Only nitrogen has 2 isotopes and they are 14 nitrogen and 15 nitrogen. Phosphorus has only 1 isotope, that is 31 phosphorus. Arsenic also has 1 isotope, that is 75 arsenic. Antimony has 1 isotope, that is 121 antimony. Bismuth also has only 1 isotope, that is 209 bismuth. So with this, the isotopes of group 15 elements over. Then finally we have to think about the electronic configuration. Here for simplification, I have taken only the valence shell electronic configuration. Dear students, the general electronic configuration of group 15 element is ns2np3. For each element only there will be a change in the n value. Okay, for nitrogen the valence shell electronic configuration is 2s2 2p3, and for phosphorus it is 3s2 3p3. For arsenic it is 4s2 4p3. For antimony 5s2 5p3, and for bismuth it is 6s2 6p3. So with this, the physical properties of group 15 elements over. What are the things we have discussed here? Physical state. The only gas of group 15 element is nitrogen. The remaining elements are solids. Then atomic numbers we know 7, 15, 33, 51 and 83. And isotopes also we have seen. Only nitrogen has 2 isotopes. Remaining elements possess 1 isotope. Then electronic configuration. The general electronic configuration is ns2np3. Okay, now let us see about nitrogen. How to prepare nitrogen. The methods of preparation of nitrogen. Dear students, there are 3 methods suggested. The first one is industrial preparation, second one is from sodium acid, and third one is by the oxidation of ammonia using bromine water. So these are the 3 methods given for the preparation of nitrogen. Let us see them one by one. Look at the first method of preparation, that is industrial preparation. Here what method is follows? By the fractional distillation of liquid air. The liquid air is taken, and when it is distilled, what do we get? We get the product nitrogen. So this is the industrial method of preparing nitrogen molecule. Then second one is from sodium acide. What is the formula of sodium acide? This is the formula NaN3. Okay, when sodium acide is subjected to thermal decomposition. Okay, what do you mean by the term thermal decomposition? The word thermal represents heating process. So when we heat this sodium molecule, it undergoes decomposition and we get the product nitrogen. Look at the equation now. Sodium acide is taken, NaN3. When it is heated, when it is subjected to thermal decomposition, it is decomposed into elemental sodium and molecular nitrogen, Na plus N2. Then come to the third method of preparation. In the third method, what is taken? Oxidation of ammonia, and here the oxidizing agent is bromine water. What is the formula for ammonia? NH3 is the formula for ammonia. When NH3 is oxidized using bromine water, there are two products we get. They are ammonium bromide and molecular nitrogen, NH4Br and N2. So these are the three methods given in your textbook for the preparation of nitrogen. What are they? The first one is fractional distillation of liquid air. It is followed in industries. Then second one is thermal decomposition of sodium acide. And finally the oxidation of ammonia using bromine water. Okay, now the properties of nitrogen we have to see. Look at the first property. It is rather inert. What do you mean by the term inertness? Inert means unreactive. Then we have to find the reason for this unreactivity. It's given in the next point. The inertness is due to high bonding energy. The bonding energy of nitrogen is very high, so that its reactivity is poor. Okay, now there are two chemical properties. Totally there are four chemical properties. In this slide we will see two, then in the coming slide we will see the other two. Okay, look at the first chemical property, reaction at room temperature. As we have seen already, its reactivity is very poor, no? So at room temperature it doesn't show any reactions. This is the only one reaction nitrogen shows at room temperature, that is with lithium. When nitrogen combines with lithium, we will get lithium nitride, that is Li3N. Okay, and this is the most important reaction because this is the only one reaction can be carried out at room temperature. All the other reactions are carried at extremely higher temperature. Then come to the next chemical property, reactions at higher temperature. When nitrogen is allowed to react with calcium, the product is calcium nitride, and here the reaction condition is red hot temperature, which means at extreme higher temperature this can be carried out. Okay, so when calcium is reacting with nitrogen, the product is calcium nitride, and at the same way when boron is reacting with nitrogen, the product is boron nitride. Here the temperature is more than red hot, so it's given by the term bright red hot. Okay, so these are the reactions of nitrogen with metals. With lithium it forms lithium nitride. This is the reaction to be held at room temperature. Then calcium on reaction with nitrogen, we get calcium nitride. Here the reaction condition is a red hot condition. And boron, when allowed to react with nitrogen, the product is boron nitride. And here the reaction condition is bright red hot. Okay, now look at the next chemical property, that is reaction with hydrogen. Reaction of nitrogen with hydrogen. It is given by the term Haber's process. Okay, it's very important process. In the industries this method is followed to prepare ammonia. Okay, and when we carry out this reactions, there are certain conditions to be maintained. Those are given here. High pressure to obtain ammonia in higher percentage, high pressure is maintained. Then optimum temperature, moderate temperature is maintained. Then there is a catalyst, that is ion catalyst. Okay, so these are the three conditions to be followed to get the ammonia in higher yield. What are they? High pressure, optimum temperature, and ion catalyst. Now look at this equation. This is the chemical equation which represents the reaction of nitrogen with hydrogen. When N2 is allowed to react with 3 molecules of hydrogen, what do we get? We get 2 molecules of ammonia, and it is an exothermic process. What is called as exothermic process? heat is liberated during the reaction, and so the delta H value will be negative. That is given in your textbook. Delta H, that is equal to minus 46.2, which means during the formation of ammonia, 46.2 kilojoule per mole of amount of energy is released. Okay, it's an exothermic process. Okay, so Haber's process, don't forget, it is very, very important one. Then come to the next reaction, that is reaction with oxygen. When nitrogen is allowed to react with oxygen, the product is nitrous oxide. What is the formula of nitrous oxide? N2O is the formula of nitrous oxide. This reaction also have to be maintained only at higher temperature. And here there is a speciality is there. Even if it is heated at higher temperatures, look at the temperature range 3473 Kelvin. Even at this higher temperature, the yield is very poor, that is only 4.4%. Okay, so the reactivity of this shows the poor reactivity of nitrogen. Okay, so when nitrogen is allowed to react with oxygen, the product is nitrous oxide, that is N2O. And this reaction to be carried out only at extreme higher temperature, but even at extreme higher temperature the yield is very poor, only 4.4% of yield is obtained even at 3473 Kelvin. Okay, and this is the chemical equation which shows the reactivity of nitrogen with oxygen. Look here, 2N2 plus O2, which gives 2N2O. Nitrogen upon reaction with oxygen, we get nitrous oxide. So with this, the chemical properties of nitrogen over. Then finally we have to see the uses. Okay, look at the first use. It is used for the manufacture of ammonia. Ammonia can be prepared using nitrogen. Then nitric acid can be prepared. Also calcium cyanamide can be prepared. So it is used for the preparation of ammonia, nitric acid and calcium cyanamide. Then second use is very, very important. Liquid nitrogen temperature, it is around minus 195 Kelvin. So that temperature is very, very important because it is used for producing low temperature required in cryosurgery. There are certain medical techniques have to be followed only at very low temperature. So for maintaining such low temperature, what can be used? Liquid nitrogen can be used. And also in the biological preservation, to keep the organisms alive, this liquid nitrogen temperature is necessary. So in the biological preservation, what is used? Liquid nitrogen is used since it gives very low temperature. Okay, so with this the uses of nitrogen is over. Okay, dear students, what are the things we have seen in this video? We have seen the occurrence, physical properties, nitrogen, and only up to nitrogen we have seen. About ammonia we will see in the coming video. Okay, and the elements nitrogen, phosphorus, arsenic, antimony and bismuth are the elements of group 15. And occurrence we have seen. Then physical properties of group 15 elements also we have discussed. Then the methods of preparation of nitrogen we have seen. Then its properties, nitrogen is rather inert, it is due to its higher bonding energy. And the chemical properties we have seen. About Haber's process we have seen. And finally the uses of nitrogen. Okay, dear students, with this video ends. About the preparation properties and uses of ammonia we will discuss in the coming video. Thank you.